In this video, we will try to find the vertex, focus, directrix, and the axis of symmetry of a parabola. For basic concepts on parabola, you can check the previous video lecture. You can also pause this video to try these yourself, and just continue to check your answer. Now, without further ado, let's start. For the first given, this is a simple equation of a parabola, when its vertex is at the origin. The first thing we need to know about parabola is, we have to identify if it is vertical or horizontal. And if it is vertical or horizontal, where does it open? If x, or x minus h is squared, then the parabola is vertical. It can open upward, or downward. However, if y, or y minus k is squared, then the parabola is horizontal. Meaning it either opens to the left, or to the right. So, going back to the given, this is a vertical parabola, since x is squared. The vertex is at the origin, or 0, 0. For the axis of symmetry, let us try to pull out a Cartesian plane to better visualize the concept. The axis of symmetry of any parabola will always pass through the vertex and the focus. If the parabola is vertical, then the axis of symmetry is also vertical. If the parabola is horizontal, then it is also horizontal. Hence, in this given, the axis of symmetry is x equals 0, or the y-axis. Now, to find the focus and the directrix, we have to find first, the focal length or c. The equation of a vertical parabola whose vertex is at the origin, is x squared, equals, 4cy. Note that the coefficient of y, is 4c. Therefore, in this given, 4c is equal to 14. With 4c equals 14, solving for c means that, we have to divide both sides by 4, so that, we have, c equals 14 over 4, or 7 over 2. Now that we know the value of c, since it's positive, then the parabola opens upward. To find the focus of the parabola, we can visualize it with a Cartesian plane. By counting 7 over 2, or 3.5 units above the vertex, we will have the focus at 0, 3.5. The directrix is the horizontal line that is 3.5 units below the vertex. So, the equation of the directrix would be y equals negative 3.5. Next given is also in standard form, but, as you can see, its vertex is not at the origin anymore. This given is in this standard form, so the parabola is horizontal. As you can see, 4c is the coefficient of x minus h. Therefore, the given has 4c equals to negative 10. Solving for c, we have to divide both sides by 4, so that c equals negative 10 over 4, or negative 5 halves. Since the value of c is negative, then the horizontal parabola opens to the left. Its vertex, as shown on the equation using the value of h, and the value of k, is negative 3, 4. The axis of symmetry is the line, y equals 4. We can, again, use the Cartesian plane for visualization. As you can see, the horizontal parabola must have a horizontal axis of symmetry, that passes through the vertex. And that is the line, y equals 4. As for the focus, we can move 5 over 2 or 2.5 units to the left of the vertex, to get, negative 5.5, 4. Lastly, for the directrix, we must move 2.5 units to the right of the vertex, in order to get, the line, x equals negative 1/2, or negative 0.5. For this third given, we have x minus 3 squared equals 4y. This time, let's try not to use a Cartesian plane to visualize the given. Instead, we will use a pattern that you might have observed from the first two problems. To start, this is a vertical parabola, because we have x minus h as squared. Our 4c is 4, because it is the coefficient of y. And because it is positive, it means that the parabola opens upward. Our vertex, with the values of h and k, would be 3, 0. The axis of symmetry is x equals 3. And here's the trick. Check your standard equation to know which between x or y is squared. In this case, it's x. Therefore, your axis of symmetry must be a line that starts with x equals some value. But what value? Now look at the x-coordinate of the vertex, and equate it to that value. Hence, the axis of symmetry must be x equals 3. Now, every time you identify the axis of symmetry, you just need to look at whether the x or y is squared. If y is squared, then your axis of symmetry must be y equals some value. Check the y-coordinate of the vertex to determine that value. Now let's find the value of c from our standard form. 4c is the coefficient of y. In this case, 4c is equal to 4. Solving for c, we have to divide both sides by 4, so that we have c equals 1. Now for the focus and the directrix, here's the trick. Remember, when you're looking for the equation of the axis of symmetry, you check the variable that is squared. This time, for focus, you deal with the variable that is not squared. That is, in this given, it is the variable y. All you need to do is to add the value of c to the coordinate of the vertex that is not squared. In this case, we have to add 1 to the y-coordinate and just copy the x-coordinate. That will give us focus at 3, 1. As for the directrix, you will start the equation to the variable that is not squared also. In this case it's y. So your directrix must be y equals some value. But what value is it? Then you have to subtract the value of c to the coordinate of the vertex that is not squared. In this case, it is y-coordinate. Subtracting 1 to 0, we have y equals -1. Hence, the directrix is y equals -1. For this last problem, it's not in the standard form. Instead, the equation is in the general form of a vertical parabola, since x is squared. We also have the general form of a horizontal parabola, like this. Going back, it would be difficult to determine the parts of the parabola, if we are not able to write this in standard form of equation. And we can write general to standard form of equation by completing the square. To start, rewrite the equation so that the variable that is squared, an other term containing that variable is on the left side of the equation, while everything else is on the right. Just like this one. Then, we will use completing the square to the left side of equation. To complete the square of the left side of the equation, divide the coefficient of x by 2 and square it. In this case, we divide -6 by 2 to get -3, then square it to get 9. Add 9 to both sides of the equation. We will now have the perfect square trinomial. Rewrite the perfect square trinomial to a square of binomial, and we will get x minus 3 squared. Lastly, simplify the right side of the equation, and we will get 2y plus 0 or 2y. And that is how we write a general form of equation to standard form. We can now easily identify the parts of parabola, using this. So, our parabola is vertical, since x is squared. and it opens upward because c is positive. From the standard form, h is 3, and k is 0, so the vertex is at 3, 0. For the axis of symmetry, check the variable that is squared. In this case it's x. So the axis of symmetry must be x equals some value. To find that value, look for the coordinate of the vertex, that is squared. In this case, the x-coordinate. Hence, the axis of symmetry is x equals 3. As for the focus and directrix, solve for c. The coefficient of y is 4c. So, we have 4c equals 2. Solving for c, we have c equals 2/4 or 1/2. So for the focus, we add the value of c to the coordinate of the vertex that is not squared. In this case, we add 1/2 to 0, then copy the x-coordinate. Hence, our focus is 3 1/2. Last, for the directrix, we start with the variable that is also not squared. Just like in the focus, in this case, we start with y equals some value. Then the value of y would be the coordinate of the vertex that's not squared minus c. So we will subtract 1/2 to the y-coordinate of the vertex, which is 0. So the directrix is y equals -1/2. And that is how you do the trick in finding the parts of the parabola given its equation. Check out the other videos for more challenging problems on parabola. Thank you again for watching. Hope you learned something from this video. If you do, kindly give us a like, subscribe, and hit the notification bell to get more lessons in mathematics for senior high.